When it comes to snow, some of the heaviest snow is lake effect snow. Now, we don't see it too much here in the greater Cincinnati area, at least the amounts that accumulate to 100, 200 or more inches. But just to our north, it's a different story. Some of these video images from over the years showing lake effect snow at its worst. Heavy bands of snow forming, well, across the Great Lakes. That's where the name came from. And it can quickly reduce visibility within a mile or two. A mile down the road, beautiful. Where you're at, a completely different story. So the question is, what are the exact lake effect cities? There's a couple out there, especially along Lake Erie. And Lake Erie, one of the more shallow of our Great Lakes, in fact, the shallowest. We do look at heavy lake effect snow that forms just east of Cleveland to Erie, Pennsylvania. Now, they can see 100 inches or more of snowfall a year. Compare that to Cincinnati's 22, 23 inches on average. That's a lot of snow. Buffalo, New York, 150 plus. Syracuse, 200 plus. Then another pretty Arctic region for lake effect snow, you have to head out towards Marquette and Kalamazoo, the upper peninsula of Michigan, where they can see 100 plus inches of snow. So how does it form? Well, you need warm waters of the lakes. And then cold air. That's why we get our heaviest lake effect snow in early fall and early spring. As that cold air comes across the warm waters of the lake, well, it's a perfect recipe. Check out this radar animation. You can see the bands, they're forming, and they basically come right across the lakes and then into high ground. Now, these images are pretty spectacular. This is a partially frozen Lake Erie. Look at it now, completely frozen. That's a good thing because that shuts off the Lake Erie snow machine, cutting down the snowfall that's to the north. Now, how do we see lake effect here in Cincinnati? Well, number one, typically when you have a west wind, it picks up the moisture and then it carries it into places like Buffalo, New York, Erie, and the eastern suburbs of Cleveland. But when the winds shift and they're more northwesterly, that's when we see a little lake effect coming our way. And it actually can come into Cincinnati in the form of cloud cover, not necessarily snow. So yes, the Great Lakes, they affect us here at home. If there's one term I want you to remember, lake effect squalls. That's right, a squall line can form. It's like the leading edge of a storm, but within these squall lines, you have near blizzard conditions. The only difference, they're more localized areas of snow. Now, when you talk about snow, there's different varieties. You have wet snow, you have dry snow, you have that feather-like flaky snow that flies in the sky. So what makes snow? Well, of course, we have water, but what types of water? Steve Horstmeyer's in the Weather Lab to explain how different types of snow are made.
Hi there, I'm Steve Horstmeyer, Chief Meteorologist here at Fox 19. Time for Weather Lab. One of the forecast problems we face every winter is whether it's going to be rain, freezing rain, sleet, or snow. And the concept behind that is pretty simple, although the forecast doesn't always work out as simply as the concept does. Take a look at this. Cold air moves in from the north, passes through the Cincinnati area. It stops before it gets down here to Lexington. Warm, moist air then rolls northward up and over that dome of cold air, and we begin to get clouds and precipitation. Well, when you get down here, the precipitation falls as rain in Lexington. When it's falling through just a little bit of the cold air near Cincinnati, we get that cold rain that nobody likes. A little bit further north, where the cold air is deeper, those raindrops freeze on the way down, and they become sleet. Well, in between the rain and the sleet, some of that rain may hit cold surfaces and freeze on contact, and we call that freezing rain. When you get way to the north, the air is deep and cold, and it falls through as snow. That's how we get the different kinds of winter precipitation. Thanks for joining me.